Hi there. I would like to talk about what is it that we do at the Center for Hardware Security at TalTechi. My own simple definition of hardware security is the study of all bad things a malicious actor can apply to an integrated circuit or to a system composed of integrated circuits. Now, among those actions, researchers in this area typically study problems such as reverse engineering, piracy, hardware Trojan horses, and backdoors. But in order to really understand what these vulnerabilities are, one must first understand how integrated circuits are designed. The ecosystem that supports this activity is incredibly distributed. For instance, when my research group does even a relatively small circuit that is only for academic purposes, I need to interface with a handful of companies in the US, in the UK, in Taiwan, and in Singapore. Now, for commercial products, this list gets even longer. And precisely here lies the problem. I have no ownership or control whatsoever over any of those companies, so I cannot rule out the presence of malicious actors in my supply chain. For instance, I can purchase a memory controller, and this controller comes with a backdoor that allows a clever adversary to access privileged data. Or, in another similar example, I hire a company to fabricate 1 million units of my chip, but they decide to produce 1.1 million parts and sell the extra ones in the black market. To summarize, and in very simple terms, what I do in my research is to find ways to design trustworthy circuits despite the untrusted supply chain that I have to operate within. Our center here at TalTechi is currently developing an array of obfuscation approaches to make the circuits harder for an adversary to understand. If an adversary cannot understand a circuit, he or she cannot copy it. If the circuit is not fully understood, any malicious modification, such as a backdoor, is unlikely to leak any privileged data. Another research approach we make use of is misdirection, where instead of preventing an attack, instead we flag portions of a circuit as really attractive to an adversary. But in the end, these portions are unrelated to the overall functionality. This is just one example of the many solutions we develop to stay one step ahead of hardware adversaries.